Hi guys, so let's talk about section 9.6, which is about the law of cosines. Okay, so the last two lessons were about the law of sines, and you might ask yourself, well, if I already know how to solve a triangle with law of sines, what do I need more? So remember, we started out chapter 9 talking about right triangles and talking about SOHCAHTOA and saying I can find the sine, cosine, or tangent and solve a triangle that way if it's a right triangle. Okay, and find all the missing pieces of this triangle. Okay. Um, then we said in section 9.5, what if the triangle is not a right triangle? And then we said, oh, there's something called the law of sines that we can use to solve those triangles. So when the triangle is no longer a right triangle, and these angles are any angles, okay, not necessarily one of them being right, how do I solve it then? And we said, well, the law of sines gives us some tools, but actually it doesn't let us solve any triangle that's not a right triangle. It only lets us solve these three cases: the as case, the asa case, or the sa case. Okay, angle, angle, side, angle, or side, side, angle. And we did these two cases in the first lesson. And we did this case, which has by itself three different scenarios as well. So remember, in this case, you could have no triangle that meets the criteria given, one triangle that gives the criteria given, or that meets the criteria given, or two triangles. Okay, so the side-side angle case was the annoying case that had three different scenarios using the given information. Okay, but important thing here is just note that this is not all the triangle cases. So there are two cases we're going to talk about today that are not included here. Okay, so what if you're given a side, let's say C, and an included angle, let's say A, and another side, let's say B? That's side, angle, side scenario. If I'm given that, you can see that I can't solve it using the law of sines. Okay. The other option is, what if I'm given three sides only? For the law of sines, I need at least one angle. And for the law of cosines, you can see that I can actually solve a triangle if it has only three sides given. Okay, so the summary here is that, and I think if you really want to do this, I think you should do this. I think you should stare at this long enough right here. Here's the law of cosines, three cases. Okay, just like we had for the law of sines, three cases. If you stare at this long enough, you'll see that this makes sense. I need two sides in an angle, or I need three sides to be able to use this formula. Okay, any of these formulas. And I think if you stare at it long enough, you should get it. So stare at it, okay, and then I'll explain it to you. So hopefully you've stared at it now for long enough, and then I'll explain it to you. So, I mean, this makes sense. Look at what's going on here. Side A is an unknown at this point. Side B is an unknown. C, B, and C, those are the same as these two. If I know those two, I know those two. And then I have angle A. All right? So what we're saying here is, for me to be able to use any of these formulas, if I know two sides, so let's say I know side B and side C. Let's say I know B and I know C. All right? Then I know this and I know that. Then for me to find A, I would need to know angle A. All right? So notice this is two sides and this is an angle. So side, angle, side. Okay? And more specifically, B and C are the two sides that have A as the included angle. Okay? So it's always side, angle, side, and this is the included angle. All right? So that should be pretty obvious. Okay? If I know two sides, A and C, let's go over here. Let me erase this stuff. if I know side A and I know side C, then I need to know the included angle. Okay, so here's A and C again. Check, 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 check. If I know the included angle B, then I can have all these unknowns that I can plug in, and then I'll get the answer for what B squared is. Just take the square root. All right? And so on and so on and so on. Likewise, if I know all three sides, then this happens. So let me use a different color. If I know all three sides, let's say I know C, A, and B, what happens? Okay, if I know all three sides, I can basically decide which angle to find. Right? Just pick a formula, and you can find any of the angles. Okay, so if I know side A, yes, I know side B, I know side C, I know side B, I know side C. The only unknown then is A. So if I plug in all these numbers, I can solve for A, and out pops the answer for the measure of angle A. Okay, same thing here. If I know B, and I know A, and I know C, I have all three sides. Then I know those two, but I don't know angle B. But that's okay. I can plug in all these unknowns, okay, and then I can solve for cosine. I can solve for B, okay, taking the inverse cosine. All right, so that's how. I mean, if you really, I really recommend that you just stare at this triangle a little bit and stare at the formula, and this should dawn on you. Oh yeah, I can see why I have to use this formula. Can only be used when I have these pieces of information. Okay, and just like for the law of sines, you pick when to use which formula. So if my missing piece of information is angle A, okay, then I would use this formula. Now if my missing piece of information is angle A, I must have been given all three sides, because if I don't have an angle, I must know all three sides. Okay, so if my missing information is angle A, then I'll use this formula, plug in the stuff I need, and then solve for A. Alright, that's how that works. If my missing information is angle B, then I'll use this formula, because I should know all three sides. If my missing information is angle C, then I'll use this information, because C is the angle I'm trying to find, but I know everything else. Okay, and likewise, if my missing information is side A, I don't know what this is, but I know what B squared, I know what B and C, I know what B and C, yeah, that's right, B and C, and cosine A, I know angle A, then I'll use this formula. If I'm looking for for side A, I'll use this formula. If I'm looking for side B, then I'll use this formula. If I'm looking for side C, then I'll use this formula. Okay, so you need to decide which formula you're going to use based on what information you're looking for, what you're trying to find. All right? So that's all fine, but we need to make sure that you understand how this even comes about. How do I even go from this to that mess over there? Okay, and so we did this for the law of sines. We showed you one way to derive the law of sines. I'm going to show you how to derive. It's not really a proof. It's more of a, I mean, even online they call this a proof, but it's really just deriving the law of cosines. Okay, proof is a very strict term that requires a lot of work. Okay, so we'll just call it deriving the formula for the law of cosines, and we're just going to do this one right here. Okay, we'll just do the first one. If you understand how the first one works, then you can do the other two as well, just like the law of sines, same thing. Okay, so let's do the first one. So we took this triangle, and all I did was drop in an altitude. Okay, I just dropped in this altitude h. Okay, and then I said, if I drop in the altitude here, what's the distance from here to here? And I just called that d. And if that distance, if the whole distance, now you know this, I mean the length of the side opposite b is small b. So the whole distance here is small b. You know that already. So then and I said that let this side length be D, then this little piece right here, let me maybe do this in a different color, this little piece right here must be this whole thing minus that thing. Okay, that would give me the leftover segment B minus D. So that's all we've done here, is just decided to label the triangle in a specific way. Okay, so you have this, nothing strange there, we just dropped in an altitude and said what do we want to call this distance right here, and then that means this distance has another length. Okay, that's all. That's the triangle, same triangle. All right, so let's work on this. And what I'm going to do is, there's an easier way to do this, but I really want to take the long route because I want to show you an identity that you're going to need to know. Some of you already know it, but you're going to need to know this for pre-calculus for sure. In pre-calculus, you'll see trigonometric identities are a big part of the course, and you use them throughout all of the other mathematics you're going to do. Intercalculus and beyond, you need to know trigonometric identities. And there's one very important one that I want to introduce to you now as part of this derivation. Okay, so let's start. Let's say I'm looking from, since we're trying to prove this one, we're going to work with angle A. See angle A. Okay, so let's start from angle A and say, let's just do something simple that I know how to do. And that would be, what's sine A? Okay, so we say, what is sine A? And you say, oh, opposite over hypotenuse. So that's just H over C. Easy. And then let's say we solve that for H. Now I think we did this before for our proof of law of, or our derivation of law of sines. Okay, so what you get here is H is just C times sine A. All right, and I'm going to call this number 1. Okay, and then we do the same thing, but now instead of saying sine of angle A, let's still look at the perspective of angle A, but let's take the cosine of that angle. Okay, so if I say, what is the cosine of A, you get D over C. And then let's solve that for D. Same process we did for H. Okay, let's solve that for D. And what do I get then if I multiply C both sides here? Is basically I get D, this cancels, so D is equals to C times cosine A. Okay, and I'm going to call that equation 2. That's very important. We're going to use this later. Okay, so I'm going to prove a little identity for you that you're going to need for pre-calc, and then we'll use that identity and this information to come up with the law of cosines. Okay, so I'm going to write it out here. Use Pythagorean theorem to prove what we call in trigonometry the Pythagorean identity. Okay, so let's do something simple. Okay, we were working with this triangle right here. This triangle right here is what we were working with. Let's just use that and use Pythagorean theorem on that triangle. Okay, so what does Pythagorean theorem tell me? It tells me that the hypotenuse c squared is equals to the sum of the two squares of the two legs. Okay, so c squared equals d squared plus h squared. All right, this is a leg, and this is a leg, and this is the hypotenuse. Okay, simple. All right, so you get this, and you say c squared is equals to. Notice very nicely that equation 1 corresponds to H, and equation 2 corresponds to D. So let's plug equation 1 and 2 in here. Okay, so let's say D then would be, what's D over here? C times cosine A squared plus H. What is H over here? H is C times sine of A squared. Okay, so what? So let's move on and get, let's square this and keep going. C squared is, now remember, if you square a product, you just get the product of the squares, okay? So I get C squared times cosine. Now, please, this is a notational thing. You'll see in trigonometry, the more trigonometry you do, we write it like this, cosine squared A. But what it actually means, cosine squared A actually means this, okay? These two things are the same. So it's just a notational thing. This is how mathematicians chose to write it for some reason. I think they just were lazy to write parentheses everywhere all the time because you use this a lot. So that way, and then this becomes C squared, square that, and square the sine, so times sine squared of A. Again, sine squared of A actually means this. Okay? That's what it means. Just a notation. Alright. So, what do I have now? Okay, I can, not really anything going on here, but C squared equals, only thing I can do on the right hand side now is see that there's both terms have a factor of C squared. So I'm going to factor out C squared, and what remains in here is this, okay? So I took that C squared and factored it out of each term. So now what I can do is, excuse me, divide by C squared, and that's gone. So what do I have left? 1 equals cosine squared A plus sine squared A. And you can switch that around, and this is usually how we write it. 1 equals, actually, this is usually how we write it. Sine squared A plus cosine squared A equals 1. Okay? And that is called the Pythagorean identity. Okay, for trigonometry, Pythagorean identity. Actually, there's a Pythagorean identity for statistics as well. It's this Pythagoras, that guy was onto some stuff, okay? God gave that guy some sweet, sweet insight. All right? So, this is the Pythagorean identity. Sine squared A plus cosine squared A is 1. So this is super important. I'm going to call this equation 4, let's say. No, maybe equation 3. Call this equation 3. Okay? All right. So, we haven't proved anything yet. Basically, we said we've established this quantity right here, this quantity right here, and we've established that sine squared A plus cosine squared A equals 1. All right? So let's go back to the triangle. Let's go back to the triangle and try and do something to establish this form of the law of cosines. Okay? Now, if I'm trying to prove that, it might be helpful that I start with something that says a squared. Okay? So let's do that. Let's look at this triangle right here and just use our knowledge we have right now to try and prove this. Okay? So let's talk about a squared, since I want to prove this for a squared. And let's say, can I write something in terms of a squared? So I have the Pythagorean theorem that says a squared equals h squared plus b minus d squared. Okay? For this little right triangle, that's the Pythagorean theorem. So I'm going to write that. So let me switch to yet another color here. Let's do this, okay? So we're going to do that, okay? Let's derive the law of cosines. Okay? Let's do it. So I'm going to say a squared equals h squared plus b minus d squared. So this side squared equals this side squared plus that side squared. Okay? And that's my Pythagorean theorem for this little triangle. Okay. So let's simplify that a little bit. A squared equals h squared plus, and I can expand this. All right? I can expand that to get... Actually, let's just leave it like that, and let's do this. Let's do this. The proof I have on my completed note sheet works this way, so I'll stick with that one. I have an h here, and I have h here. Okay? So I can take this h and plug it in here. Okay, so I'm going to say h squared is c times sine of a squared. Okay, and then I have plus b minus d, but now notice, again, I have d here, so I can plug that in here. Okay, so I have b minus c times cosine a squared. All right, so let me clean this up a little bit. Okay, all right, so this is what I have. So at this point, we're actually done. We just have to simplify things, and you'll see magically this equation just emerges. Okay, magically it just emerges. So let's see what happens. So I do, all right, a squared is, and square this again. Now we just did this a little bit earlier. This just becomes c squared times sine squared a plus, now this is harder. This is a square of a binomial. Okay, square of a binomial, two terms. So what I get here is b squared, square the first term, check. Then minus 2 times bc cosine a. Okay, that's the middle term. And then square the last term, plus c squared cosine squared a. Okay, check, I squared that one. All right, so square the first term, that's this. And then b times c cosine a times 2, that's this. And then square the last term, that's this. Okay, now that's sometimes not people's favorite thing to do, but that works. That's just literally a square of a binomial. All right, we're almost there. So now what can I do? Look up here. I want a b squared and a c squared. Okay, so here's what we do. You say a squared equals, I have a b squared, let's put it in the front. Okay, that's what I want. Check, happiness. And then I want a c squared. So notice now we have this going on. Here's a c squared, and here's a c squared. So how about we put those two things next to each other? Okay, let's just rearrange. C squared times sine squared a plus c squared times cosine squared a. And then let's leave this thing in the back. Okay, minus 2bc cosine a. Now you look at this and go, ooh, that's looking good. Minus 2bc cosine a, I already have that. And I have b squared and a squared. Ha, we're almost there. Okay, so if you look at this carefully, ooh, something should be jumping out at you. I see something similar going on here. Okay, so you say a squared is b squared plus, how about I factor out a c squared again, and I get this, sine squared a plus cosine squared a minus 2bc cosine a. And now we know, wait, equation 3 says that cosine squared a plus sine squared a equals 1. This is just 1. So I have a squared equals b squared plus c squared minus 2bc cosine a. And that is the Pythagorean, that is the law of cosines for the case where you're trying to find side A. Okay, that's the first case right there. So we have it. Happiness, happiness. Maybe you think it's sadness. Okay, so we have it. So we did it. So that's how you can go from a little triangle like this to that. Okay, it takes some work, but there it is. Someone proved it. Now you can just use it. Okay. All right. And we said that what do we call the father of trigonometry, like Apollonius or someone? Okay, so we do know some people that were responsible for doing these things. All right, so that's how it comes about. Let's go and actually use it now. Let's just use the law of cosines, okay? So let me do example 1. Example 1 says, what if they give you 3 sides? Can you use law of cosines to solve the triangle? Remember, solve the triangle means if they gave me 3 sides, then my task is to find the missing angles. Oh, that's nice. There we go. Find A twice. Find the missing angles. Okay? So that's what we're going to end up doing here. So my strong suggestion to you is draw a little picture just to make you understand what's going on. So A, B, C. And again, pictures not to scale. Things don't look necessarily right. That's okay. It's just a little bit of a visual representation of the abstract information they gave us. Okay? Alright, so what am I trying to find? A, B, and C. That's the missing stuff. So they don't tell you what to find. They just say solve the triangle. Well, solve the triangle means find all the missing things. And the missing things are the three angles. So let's do it. Okay? Now, I'm trying to find a missing angle. So I need to use basically all three of these formulas, or at least two of them, because I need to find an angle and I need to find another angle. Once I have two, I don't have to use this formula again. Once I have two, I can use the triangle sum theorem. Okay? So I'm going to use law of cosines twice. So which one you use doesn't really matter. I like going alphabetically, so I'm going to try and find angle A first. So then you use the formula that has angle A in it, which is the first one. Okay? So it's A squared equals B squared plus C squared minus 2BC cosine A. Okay? And you got to memorize this, like law of sines and cosines and basic trigonometric ratios. We're not going to give you this information. You need to know this stuff. Okay? Very, very important. This one, not too difficult to memorize. I mean, you've got A squared ends with cosine of A. It's not that difficult to memorize. Okay? Alright, so let's plug stuff in that we know and then find what we don't know. Okay? So what do I know? I know side A is 14. So 14 squared equals, I know B is 16 squared plus C, they told me, is 9 squared minus 2 times 16 times 9 times cosine A. I don't know A. This is the unknown. This is what I want to know. Okay? So, please pay close attention. Some students make really weird mistakes here, and I don't understand it, but I'm going to show you what they do and what you should not do. Okay, what you should not do. So, go ahead and square stuff. You get 196 equals 256 plus 81 minus, and then multiply this, so you get 288 cosine A. Alright? Please notice you cannot combine all three of these numbers. There is multiplication going on here. And multiplication has a higher precedence than addition and subtraction. So I cannot subtract 288 from this plus this. You can't do that. The only thing I can do right now, okay, only thing I can do right now is do 196 equals, and I can add these two, okay, which gives me 337. But then I cannot do anything with 288 because it's being multiplied by cosine A. Okay? So I can't do anything else there. Alright? So what you do now is, I can't subtract these two. Don't do that. You can't subtract them. Okay? So what you do is say, do what you can do, which is subtract this both sides. Subtract it both sides. Okay? And then what you get is negative 141 equals negative 288 times cosine A. Alright. So please, again, don't be tempted to combine these three things. You can't do that because there's multiplication here. Okay? So you need to combine the two things that you can. Get them there. Do not combine these two. Don't do that. Don't be tempted. Okay? And then just subtract the 337 to the other side. Now you got this. From here on out, it's pretty simple. You've done all the hard work. Now you're just doing divide by negative 288. And please do not on your calculator make this a decimal. Do not make this a decimal. Leave it like that. you can maybe just simplify the signs, right? So negative divided by negative is positive. So what I have is 141 over 288 is equals to cosine A. Okay? And then how do I solve this? Let me move this over a little bit. How do I get the angle out of there? You take the inverse operation, okay? Inverse cosine of cosine A and inverse cosine of this mess right here, okay? The inverse cosine is the inverse operation of cosine, so all I'm left with here is the size of the angle, okay? And then you get that's equal to exactly this. We're going to approximate it because your calculator is going to do some kind of an estimation to the truth, which is about 60.69 degrees. Okay? And please, I have the calculator up here. I think I'm going to show you something in a few minutes here. I think you can, one of the calculations you can enter in very, very quickly on your calculator. I want to show you how to do that. But just make sure we're talking here about degrees, right? See, I have my answer in degrees. Most of triangle solving, you're doing, make sure your mode is degree mode, okay? Degree mode. Otherwise, you're going to get strange answers. They'll be correct, but they'll be in radians, okay? So this is what we have. So we have our first angle, 60.69 degrees, okay? And if I were you, on my little picture, I would fill it in so you know what's still missing, okay? Very easy now. Box the answer, there she is. And let me go on to the next thing. So what else do I need to find? So I got angle A, check. So I need angle B and C. Okay? So then I go here and I have another formula that has angle B in it. So I just use that formula. Okay? Let's do that formula. Where can I squeeze it in? I'll squeeze it in right here. Okay, let me do a different color and we'll do angle, let's do blue. I'll do angle B. So B squared equals A squared plus C squared minus 2AC cosine B. Okay, that's the formula. And so I'm going to use everything I know, plug stuff in. So B is 16 squared equals A is 14 squared plus C is 9 again, minus 2 times 14 times 9 cosine B. I don't know B. Alright? And go through and square stuff and do everything you can there. So I do 256 is equal to 196 plus 81 minus, and then put this in your calculator. I think you get 252 cosine B. Okay? And then please remember, I can only combine these two things right now. Cannot do anything with 252 because it's being multiplied by cosine B, so that stays there. So I got 256 equals, and then you get 277 minus 252 times cosine B. And then subtract this both sides. Okay, and you get negative 21 equals negative 252 times cosine B. Divide by negative 252. Okay, cancel here. So what I have now, again, careful here, is 21 over 252. Don't round or make it a decimal, equals cosine B. And how do I get out of there? Again, inverse operation. Okay, take the inverse of both sides. These two cancel. So what you have left is measure of angle B is, and do that calculation on a calculator. What you get is about 85.22 degrees. Okay, so I have 85.22 degrees here, and box your answer so that someone knows where your answers are. Okay, that someone being me. And then lastly, find the last thing. So number 3, the third thing I want to find is angle C. I have angle B now. I want angle C. Okay, but that's easy. Measure of angle C is, and just use triangle sum. 180 minus 60.69 minus 85.22. And you have measure of angle C is 34.09 degrees. 34.09 degrees. And box it, and life is good. Okay? You found the missing information. Now, some students invariably say, hey, Mr. Dietliffs, once I found the first angle, can't I use law of sines? The answer is maybe, yes, probably. Okay. The only problem you have is when you do that, you can come up with some weird situation where you get a side angle case of the law of sines where you can't find another solution or some weird things happen. Okay. Sometimes this doesn't work. Sometimes if you find the first angle and you go and try and do law of sines over here, something strange happens, and some people get an error in their calculator, or they get a side that's different, and that's because you're solving actually the second case of a side angle triangle for law of sines. So I really do not recommend that you jump from law of cosines to law of sines. Okay, now if you really know what you're doing, there are some things you can look at and go, oh, okay, I know what's going on here, and solve it that way. But for the average person out there, just do law of cosines. If you have to solve the triangle with law of cosines to begin with, right here, then find your second piece of information with law of cosines, and then you can do something else. Okay? Don't jump. This is my recommendation. Okay? Do not jump between law of sines and law of cosines. Some students do that and they get really messed up by this stuff. Okay? If you start with law of cosines, just do law of cosines for that whole question. If you know how to do it some other way, that's fine. But a lot of people get messed up with that. All right, let's do another case. This was a side case. All right. I think what I'm going to do is do a side angle side case and call it a day there. And then we'll do the last example. Okay. I don't really know if it's necessary to do too many. Maybe I'll do 2 of this. I think this is the harder case, maybe. Maybe I'll do example 3 and 4. Let's see. Okay, let's see. So, I'm going to go a little bit quicker now. Hoping you're okay with this. Let's go a little bit quicker. Triangle here. I got A, B, C. Okay. And side A is 22. Side B, which would be here, is 15. That means they must give me this angle, and they did. That's 108. Okay. So I don't know angle A. I don't know angle B. And I don't know side C. That doesn't even look like B. All right. Okay. So those are the 3 things I'm trying to find. Angle A, angle B, side C. Can't use law of sines because law of sines, I need information opposite each other. That doesn't work. Okay. So I got to use law of cosines. Okay. So law of cosines. What can I do? Well, if they gave me side, angle, side, the only thing I can do now, if you look at the formulas, is actually find side C. Okay, that's about all I can do. If they gave me angle C, let's go all the way back up here. If they gave me angle C, which means then they had to have given me A and B, the only thing I can find is side C. Okay, because if they give me this angle, they must give me these 2 sides. So the only thing I can find is the side opposite the angle. Alright, so side angle side works like that. If they gave me these 2 sides and this angle, the only thing I can do is find that first. Then I can solve the rest of the triangle. Okay, so let's do that. So let's start with C squared equals A squared plus B squared minus A, minus 2ab cosine c. Okay, 2ab cosine c. And then plug in the stuff I do know. So I don't know side C, but I know side A and B. So this is 22 squared plus 15 squared minus 2 times 22 times 15 cosine of 108. Okay? Ooh. Now if you look at this carefully, you say, wait, I can enter that sucker in my calculator. Okay? And that is true. You can literally enter this whole thing in your calculator. So doing this by hand really not that important. Okay? The only thing I would recommend you do is just be careful of your rounding. So if you want to solve the whole thing in your calculator, put this in your calculator. Okay? This is a little bit complicated to type in your calculator, but do this whole mess exactly in your calculator. Otherwise, you're going to get a very inaccurate answer. Okay, so let's attempt to type this whole thing in our calculator over here. So let's do second root, and then let's do, you don't have parentheses for this really, 22 squared plus 15 squared minus 2 times 22 times 15 times cosine of 108. And what do you know? One click, you have the answer. This is the answer, okay? 30.22 if you round to the hundredth. Okay, 30.22. Box it. Done. Boom. Got it. Okay? Very, very nice. All right. So, that's good. That was actually, because of the calculator, the calculation here is actually simpler. Okay? Now you can go do all of this slowly and, you know, all that kind of stuff, but this is going to be inaccurate. This is the most accurate way to do it. Enter that whole mess in your calculator. All right. So we have C is about 30.22. Problem, I need an angle. Okay? So I found my first missing side. Great, but now I need to find one of the angles. Okay? So now you're basically back to this type of a calculation, one of these. You're going to do something like this. Okay, and that you can't just type in your calculator. So let's go back and do one of these. So if it were me, I'd like to go alphabetically. I'll just say let's find angle A. So if I want to find angle A, I need to use the formula that has angle A in it, and that's this formula. Okay, A squared equals B squared plus C squared minus 2BC cosine A. Okay, that's what I'm trying to find. There it is, cosine A. Okay? And so plug stuff in. So here I now know a whole bunch of information. I now know 3 sides, so I can find another angle. Okay? So you get 22 squared equals 15 squared plus, here's my answer we approximated earlier, minus 2 times 15 times 30.22 times cosine A. Okay? So let's see how this goes. All right? You have to just square stuff and do the calculations. You can't punch this all in your calculator. 484 equals 225 plus, if you square that, I think, and I'm going to be very accurate here, 2484, I think is what you get. Okay, if you square that. And then, so if you square this, you get that, right? Try and be as accurate as you can so you're not getting incorrect answers because of your rounding. And then 2 times, if you do that calculation, I think you get 906.6. So 906.6 times cosine A. Okay? Please remember, I don't know how many times I can say this, you cannot combine all 3 of these. Okay? Please, you can only combine these 2 because there is multiplication happening here, and that's higher precedence. So I can't subtract something that's being multiplied. Okay? Okay, so what you get is 484 equals, I think you get, if you combine this, 1138.2484, okay, minus 906.6 times cosine A. And then subtract this both sides. Man, why am I having a hard time writing that? 2484. Subtract this both sides. Okay, that's gone, and what you have left then is negative 654.2484 equals negative 906.6 times cosine A. Again, same procedure. Divide this both sides. Okay. Oh, not the cosine A part, sorry. Just divide that. Negative 906.6. This is gone. So here's what I have, and I'm going to write this all at once now. Here's what I have. I have the measure of angle A is inverse cosine of that stuff right there. 654.2484 over 906.6. And if you enter that in your calculator, you get approximately 43.81 degrees. Okay, so measure of angle A is about 43.81 degrees. All right, and now you've done two fairly long calculations. The third one, fortunately, is always easy. You're finding the missing angle, and that's much simpler because you're just saying the measure of angle C is 180 minus the measure of angle A, which is 43.81 degrees, minus the given angle, which is 108. So the measure of angle C is, it would actually be approximate, oh sorry, what am I writing? Measure of angle C, we were given C. We're trying to find measure of angle B. Forgive me, for I've sinned. We're trying to find measure of angle B. Measure of angle B then would be actually also approximately 28.19 degrees. This would be approximation because everything depends on approximation so far. Okay, so box this answer, there's that one. Box this answer, there's that one. On your picture, write 28.19 degrees, and you got it. Okay, so there's that. I think I'm going to leave it at that. Okay, I think I'm going to leave it at that. I don't think I'm going to do another one. All right. I think we did this 3 times together. We did this once, but that's not too challenging. And then, of course, you know how to do this. Okay, so let's look at the last example here, and this is Heron's formula. I did write up a proof of this. I can't remember if I posted it to Schoology, but it's pretty gnarly. Okay, so we're not going to go through and do a proof / derivation of Heron's formula. To do that would take like another hour. It's ridiculous. Okay, it's a lot of work. So, and you are really going to things that you don't know yet. You need to know some trigonometry from pre-calculus. So let's not do a derivation of this one. I know you're very sad about that, but it says here Heron in 100 years AD, after the death of Christ, or year of our Lord, because Christ is not dead. Any case, so 100 AD, Heron is credited with doing this formula. Okay, and the formula is very simple. There she is. And it says, what does S mean? You know what A and B and C means. That's the length of the sides. So now you know, for me to use this formula, I need to know all the side lengths. So I need to know SSS. I need to have the SSS case here for me to do this area calculation. But what is small letter s? Okay, let me write SSS case. What is small letter s? It's a half of the sum of the 3 sides. Okay, sum the 3 sides and take a half of it. That's it. That's simple. Okay, so how do you find the area? Well, if I need S in my formula 4 times, okay, I better find S first. So let's find S first. That's how you do this, okay? So let's do this first. So small s is 1/2 of A, and A here is 4. Of course, you see that. B is 9, and C is 7. So I have 4 plus 9 plus 7, and S is 1/2 of that, which is 20, which means S is 10. Okay, so once I have S, now I can just plug stuff in. All right, so the area using Heron's formula is the square root of S, which is 10, times S minus A, which is 10 minus 4, times S minus B, which is 10 minus 9, and times S minus C, which is 10 minus 7. Okay, and this again, let's be this simplest way to do this, just punch that whole thing in your calculator. Okay, and if you do that, you get, it's a square root of a number that goes irrational. I think it's 13.42 units squared is what you get. Okay, if you punch that in your calculator. All right, that's it, guys. That is there's your homework. I'll post it on Schoology. That is section 9.6, okay, law of cosines. If you have any questions, please let me know, and I will have a review session for you guys again before your chapter 9 test. Thanks, guys.